Hello students, from yesterday we started learning chapter Conics section, and in the previous class we have learnt about circle. What is meant by a circle and what is the equation of a circle. Equation of a circle is given by x minus h the whole square plus y minus k the whole square equals to r square, where h comma k is the center and r is the radius. Using this we have done few problems. Let us continue with the exercise 11.1. Question number 12. Find the equation of the circle with radius 5 whose center lies on x-axis and passes through the point 2, 3. The remaining problems are more or less like 11th and 10th problem. They asked you to find the equation. Radius is given. So r we know. So only if we know the center we can directly give the equation. So to find the center they have given you a clue. The center lies on x-axis. So if a point lies on x-axis, what will happen, how it will look like? Its y coordinate will be 0. So if we take the center as h comma k, then k equal to 0 since it lies on x-axis. Alright. So to find h, they have given you a clue that it passes through the point 2, 3. So now what are we going to do? We are going to substitute the point 2, 3 in the equation of the circle to get the value of h, and once we know h, we can write the equation because already radius is known and k is 0. Right? Hope you got it. I will show you how to solve this problem now. See, center lies on x-axis, therefore k equal to 0. Equation of the circle is given by x minus h the whole square plus y minus k the whole square equals to r square. K is 0. So the equation is being reduced to x minus h the whole square plus y square equals to 25. Now it is given 2, 3 lie on the circle. So if we substitute this point, we have arrived at two values for h. So when h is equal to 6, the equation is, we can substitute the value of h here. So we can get the equation. When h is equal to minus 2, so we got the 2 equation of the circle. I hope you got it. Let us move on to the next question now. The next question is, find the equation of the circle passing through 0, 0 and making intercepts a and b on the coordinate axis. So it passes through one point and making intercepts a and b, which means on the coordinate axis. So its x-intercept is a and y-intercept is b. So which means the point a, 0 and 0, b lies on the circle, right? So as of now we got 3 points lying on the circle. They didn't talk about the radius or any other clue. Instead they have given you it passes through 0, 0 and making intercepts, which means it passes through the point a, 0 and 0, b. So totally they have given you 3 points lying on the circle. They asked you to find the equation of a circle. It is like a usual procedure. Let us see how can we solve this now. Now as usual, the equation of a circle is given by x minus h plus y minus k the whole square is equals to r square. Since it passes through the point 0, 0, if we substitute x as 0 and y as 0, what we will get? We got h square plus k square equals to r square. This is the relation between h, k and r. So since they didn't talk about r in the entire question, this is an important relation which we arrived at between h, k and r, because it is enough if we find h and k. We don't want to find r because r square is equals to h square plus k square. So if we find h and k, we can very well find our r square directly, right? Now it passes through the point a, 0 and 0, b. So the same way again we have to substitute in the equation of the circle the point a, 0 and 0, b in order to find our value h and k. Now if we substitute the point a, 0, what will happen in the place of x? Don't get confused. In the place of x and y only we have to substitute this point, not in the place of h and k. So a minus h the whole square plus 0 minus k the whole square. Similarly 0, b. Alright. So we got two equations now. Normally we have done a problem of this kind previously where we equated these two equations to obtain h and k, right? But here we cannot do that because we have already a and b, two unknown things. So what are we going to do here is, we are going to take the first equation and in the place of r squared, we are going to replace it with h square plus k square, because r square is h square plus k square, right? So we have taken the first equation, in the place of r square we are going to replace it h square plus k square, right? Now expand it using a minus b the whole square identity. So h square k square, it's getting cancelled. So if we take a as common, a minus 2h is equals to 0. So either a equal to 0 or a minus 2h equal to 0. But it is clearly a is not equal to 0 because they have given in the question that it is a x-intercept, right? So a is not equal to 0. If a is not equal to 0, we will get a equal to 2h. If a is equal to 0, we will get just 2h. h is equal to 0, right? Since a is not equal to 0, a equals to 2h. Therefore, what will be the value of h? H is a by 2. So, we found the value of h now, right? Similarly, we can take the equation in b. Again, we can simplify. Again, b is not equal to 0. So, from that we can find what is k value. So, we found what is h and k. So, as I told you, we don't want to find r here because r square can be replaced by h square plus k square. Hence, the required equation is x minus h is a by 2 the whole square plus y minus k the whole square, which is equals to r square. R square is h square plus k square. So, h square plus k square. Now, expand using a minus b the whole square identity and then simplify, we will get the required equation. So, whatever the thing is, if you check out the procedure, it's similar. They will give you a point on the circle and they will give you some clues. So, write the equation of the circle, substitute that point and try to find your center and the radius. Only then you can write the required equation of the circle. Our ultimate aim is to find the center and the radius. Yes, hope you got it. Let us move on to the next question. Now the 14th question. Find the equation of a circle with the center 2, 2 and passes through the point 4, 5. They have clearly given you the center and it passes through the point. So if we know the radius, we can very well find the equation of the circle because center is directly given in the question. So how to find the radius? See, they have given you the center and a point on the circle. What is the distance between the center and a point on the circle? Which is nothing but the radius. So, apply distance formula between these 2 points. Then we can find what is our radius. Once we know the radius, we can substitute in the equation of a circle formula. That's it. Right? Now, we are in the last question of the exercise. They asked you, does the point minus 2.5 comma 3.5, does this point lie inside, outside or on the circle? The question is, does this point lie inside, outside or on the circle? X square plus y square. The circle equation is x square plus y square equals to 25. They have given you the equation of a circle. So, from the equation of a circle, we can very well see the center is 0, 0 because it can be written as x minus 0 the whole square plus y minus 0 the whole square, which is equals to 5 square, right? So, the center is 0, 0 and the radius is 5 units. Now, they asked you to check whether this point lie inside, outside or on the circle. Now, how will you identify? If the distance between the center and the point, if the distance between the center and the point is equal to 5, then it is on the circle. Yes or no? Because the radius is equal to 5. Therefore, it will lie on the circle. If it is less than 5, then it lies inside the circle, and if it is greater than 5, then it lies outside the circle. That's it. So this is what the procedure to check where the point lies if you know the center and the radius. If you know the center and the radius, check the distance between the center and the point and correlate it with the radius. If it is equal to the radius, it will lie on the circle. If it is less than the radius, it will lie inside the circle, and if it is greater than 5, it will lie outside the circle. So I am leaving this question to you as homework. Now with this we completed the circles concept. Let us move on to the next concept now. Next we are going to learn about parabola. So far we know what is meant by a parabola. We don't know the equation and the other features of a parabola, right? We all know the graphical representation of a quadratic equation is a parabola. We have learnt in our lower classes like class 9 and 10. When we represent a quadratic equation graphically, we will get a parabola, and we know the shape of a parabola will be like this, right? But we don't know the other special features of a parabola. That's what we are going to learn in this topic. So first of all, what is meant by a parabola? A parabola is the set of all points in a plane that are equidistant from a fixed line. Equidistant from a fixed line and a fixed point which is not on a line in the plane. I repeat, parabola is a set of all points that are equidistant from a fixed line and a fixed point, which is equidistant from a fixed line and a fixed point, which means the distance between the point and the line is equal to the distance between the point on the parabola with the fixed point. So this distance is equal to this distance. This distance is equal to this distance. Likewise, the collection of all these points form a parabola, right? So a parabola is a set of all points in a plane that are equidistant from a fixed line and from a fixed point which is not on the line, right? This fixed line is called the directrix. This fixed line is called the directrix. This fixed point is called the focus, right? This fixed line is called the directrix. This fixed point is called the focus. And the point of intersection of the curve with the axis is called the vertex, right? And a line through the focus is called the axis. I repeat, the fixed line is called the directrix. The fixed point is called the focus. A line through the focus and perpendicular to the directrix is called the axis. The point of intersection of the axis and the parabola is called the vertex, right? The line drawn perpendicular to the directrix and passing through the focus is called the axis. The point of intersection of the axis and the parabola is called the vertex. These are all the parts of a parabola. Now we are going to learn what are all the standard equations of parabola. There are 4 standard equations of parabola. And we are going to learn the standard equations when the vertex is at the origin. When the vertex is at the origin and axis of symmetry is along the x-axis or y-axis. We know what is meant by the axis of symmetry, right? And looking at the curve parabola itself, we can see it is symmetrical, right? So standard equations are obtained when the vertex is at the origin and the axis of symmetry is along the coordinate axis, either on the x-axis or on the y-axis. We are going to obtain the standard equation in these cases. There are 4 standard equations: y squared equal to 4ax, y squared is equals to minus 4ax, x squared equal to 4ay, and x squared equal to minus 4ay. When y squared equal to 4ax, the parabola curve is open to the right. So when y squared term we have and x coefficient is positive, the curve is open towards right, and the curve is open towards left when y squared is equal to minus 4ax. When it is x squared equal to 4ay, it is open upward, and x squared equal to minus 4ay, it is open downward, right? These 4 are the standard equations of parabola. And these 4 standard equations are obtained when the vertex is at the origin and the axis of symmetry is along the coordinate axis, right? Now let us see how can we arrive at this standard equation. We will derive the equation of the parabola first for the first one, y squared equal to 4ax, right? Now let f be the focus and L be the directrix. Let the perpendicular to the directrix bisect at the point O. Okay, let f be the focus, L be the directrix. Let Fm be the perpendicular to the directrix. This is perpendicular to the directrix which bisect at the point O, which means MO is equal to F1. Now produce this MO2x. Produce this MO2x. By the definition of parabola, we know this distance is equal to this distance, right? That's what the definition of parabola. The definition of parabola says the collection of all points which are equidistant from the fixed line and a fixed point which is not on the fixed line, which is not on the line, right? So according to the definition of the parabola, PB is equals to PF, right? And according to the definition of the parabola, we know that the midpoint O is called the vertex of the parabola. By definition, which is called the vertex? The point of intersection of the curve with the perpendicular is called the vertex. Therefore, O is the vertex here, right? F is the focus, L is the directrix, and we have produced MO2x, right? And O is the midpoint, and by the definition O is the vertex, and we take O as origin, then OX as the x-axis and OY is the y-axis. Now let the distance from the directrix, this is what our directrix, right? So let the distance from the directrix to the focus be 2a. We are assuming let the distance from the directrix to the focus be 2a. Then how can we fix up the coordinates of the focus? Focus lies on x-axis, therefore y coordinate will be 0. Moreover, we know that O is the midpoint and this is on this side, right? Directrix on this side, therefore we know this distance is 2a, therefore this distance should be a and this distance should also be a. Therefore the coordinates of f is a, 0. And this point will be, even though the distance is a, this point is the negative side of x-axis, therefore this is minus a. Therefore the directrix equation is x is equal to minus a. Let P be any point on the parabola, and as I told you earlier, we know by the definition of a parabola PB equal to PF, right? Now we got all the coordinates. What will be the coordinates of B again? We know this is minus a and this side it is y, so minus a comma y is the coordinates of B. Now apply distance formula for PB and PF, and both are equal. If we equate and simplify, we will arrive at y square is equal to 4ax. This how only we have arrived the standard equation of a parabola, right? On the other hand, we can check any point on the parabola whether satisfies this equation or not. We told this is the equation of a parabola. We assumed a point on the parabola and then we have arrived at the equation. Now conversely, let P of x comma y satisfy this equation. Then let us check whether its distance is equal or not. So PF, and we have checked PF is f is a comma 0, right? Focus is a comma 0, and the distance between P and f we found it to be square root of x plus a the whole square, which is nothing but PB. So P of x comma y lies on the parabola. Yes, hope you got it. So hope you got it how we arrived at the standard equation y square equal to 4ax. So when we talk about standard equations, there are 4 standard equations: y square equal to 4ax, y square equal to minus 4ax, x square equal to 4ay, x square equal to minus 4ay. We have seen one equation how we arrived at. Similarly, we can derive the remaining equations as well, right? And one more important thing we have to see here is, on the standard equations, the focus is on one of the coordinate axis, vertex is at the origin, and directrix is parallel to the other coordinate axis. With all these three conditions only, we have derived the standard equations. So you have to remember the four standard equations of parabolas. Y square equal to 4ax, which is open towards your right. Y square equal to 4x, open rightwards. It focus is a comma 0 and directrix is x equal to minus a. And y square equal to minus 4ax is open leftward. So its focus is minus a comma 0 and x equal to a is the directrix. X squared equal to 4ay, open upward and its focus is 0 comma a. Y equal to minus a is your directrix and x square equal to minus 4ay is open downward. Y equal to a is the directrix and focus is 0 comma minus a. And all these four standard equations are derived when the focus is on the coordinate axis. See, here the focus is on x-axis. In these two, the focus is on y-axis. So, focus is on any one of the coordinate axis and the vertex is at the origin. All these four cases, the vertex is at the origin. And if you check out the directrix is parallel to the coordinate axis. Right? And when you correlate the equation with the focus and the directrix, you should know how to obtain it. If the equation is y square equal to 4ax, if you have y as a square term, then x will be your directrix. X is equals to minus a, where a is the focus. A comma 0 is the focus and x equal to minus a, negative of a will be the directrix. When you have y square equal to minus 4ax, then minus a comma 0 will be your focus and x equal to a will be the directrix. Hope you got it. You have to remember all these things. When your equation is y square equal to 4ax, a comma 0 is your focus and x equal to minus a is your directrix. When y square equal to minus 4ax, minus a comma 0 is your focus and x equal to a is your directrix. Similarly, when your equation is x square equal to 4ay, when x is square term, then your curve is open upward and hence the focus lies on your y-axis. When it lies on y-axis, x coordinate is 0, so your focus is 0 comma a. Remember, when it lies on y-axis, it is 0 comma a and your directrix will be y equal to minus a. When x square equal to minus 4ay, your focus will be minus 0 comma minus a and your directrix is y equal to a. Just the opposite of the other two. Hope you got it and you have to remember all these things. Next, we are going to learn about another concept of a parabola, which is called a latus rectum. What is latus rectum? Latus rectum is a line segment perpendicular to the axis of the parabola through the focus. It is perpendicular to the axis of the parabola. Which is the axis of the parabola? This is the axis, right? So it is a line segment passing through the focus and it is perpendicular to the axis of the parabola. This length is called latus rectum. So what is the length of the latus rectum of a parabola? Which is 4a. How we obtained this? It's very easy because by definition we know AC, this distance is equal to this distance, right? And also we know AF is equal to AC by definition, and also AC is equals to FM and FM distance is 2a. Therefore AC is also going to be 2a and hence AF is also going to be 2a. And this is also 2a. Therefore AB is going to be 4a. 2a plus 2a, which is going to be 4a. Therefore length of the latus rectum is 4a. Right? So for the standard equation y square equal to 4ax, we know focus is on the x-axis. Therefore it is a comma 0 and the directrix is x is equal to minus a. Latus rectum length is 4a. Right? You have to remember like this for every standard equation. Hope you got it. With all these inputs, let us move on to the exercise problems based on parabola now. Now let us see how can we solve the problems. The first question is find the focus, axis, equation of directrix and length of latus rectum for the given parabola. The equation is y square equal to 12x. So as I told you, you can remember in this way, if the equation is of the form y square equal to 4ax or minus 4ax, the axis is along x-axis, and 4ay or minus 4ay, then it is along y-axis. And the focus, I have tabulated everything for the better clarity and the remembrance purpose. So you can remember in this way, y square equal to 4ax means focus is going to be a comma 0, directrix is x equal to minus a, vertex is 0 comma 0, and in all the cases the lattice rectum is going to be 4a only, right? Now come back to this, it is of the form y square equal to 4ax, right? So in the place of 4a we have 12. So 4a equals to 12, therefore a is equals to 3. So once we get the 3, we can obtain the remaining things. What is focus? Focus is a comma 0. So 3 comma 0 is the focus. And since it is of the form y square equal to, then the axis is going to be x-axis, right? Then equation of directrix, since y square equal to 4ax, equation of directrix is x is equal to minus a. So x equal to minus 3. Then length of the lattice rectum is 4a, so 4 into 3, which is 12. That's it. So this is how you need to solve the remaining questions here. First you have to identify the format, and then accordingly you have to write the focus, directrix, vertex and the lattice rectum. If you see the second question, it is x square equal to 6y. X square equal to 6y is of the form x square equal to 4ay. And one more thing, it is not necessary that a should be always whole number. It can be fraction also. If you take x square equal to 6y, 4a is equal to 6. So a equal to 6 by 4 or 3 by 2. Right? So you can get in that way also. In that case, the focus is going to be 0 comma a. So 0 comma 3 by 2 is your focus. Your directrix is y is equal to minus 3 by 2. And your lattice rectum is 4 into 3 by 2. Which is 12 by 2 or 6. Hope you got it. So first you have to identify in which format the equation is. Then you have to find out your A. Once you get your A, you can write the remaining things. Right? Let us move on to the next question now. The next question is, they have given you the focus and the directrix. They asked you to find the equation of the parabola. So on looking at the focus, it is of the form a comma 0. So if the focus is a comma 0, then the equation is of the form y square equal to 4ax, right? So it lies on x-axis, therefore axis of the parabola is x-axis, and moreover it is of the form y square equal to 4ax. So we need to know what is our a, right? Our a is 6. So y square equal to 4 into 6 into x. So y square equal to 24x is the equation of the parabola. That's it. So from the focus, so if we know what is a and which is the axis, then we can very well write the equation of the parabola. Similarly, you can solve the 8th question. There they have given you the focus is 0 comma minus 3 and directrix is y is equal to 3. If the focus is 0 comma minus a, then it is of the form x square equal to minus 4ay. Yes, hope you can do it. Let us move on to the 9th question. 9th and 10th question is also of the same way. Vertex is 0 comma 0, focus is given. Focus is a comma 0. If focus is a comma 0, then it is of the form y square equal to 4ax. Here focus is minus a comma 0, then the equation is of the form y square equal to minus 4ax, right? So accordingly you can give the equation of the parabola if you know what is the value of a. Now let us see the 11th question. Vertex is 0 comma 0 and it passing through 2 comma 3. Axis is along x-axis. The same way they have given you the axis is along x-axis. So if the axis is along x-axis, then it can be either y square equal to 4ax or y square equal to minus 4ax. But in the question they have given you it passes through the point 2 comma 3. So 2 comma 3 lies in which quadrant? First quadrant, right? Both are positive, therefore 2 comma 3 lies in the first quadrant. Since the axis is along x-axis, it should be either open right or open left. The parabola should be open right or open left since the axis is along x-axis, right? Now we have to judge and analyze whether it is opened right or left. For that they have given you it passes through the point 2, 3. 2, 3 lies in the first quadrant, therefore the parabola should be opened right. If it is opened right, it is of the form y square equal to 4ax. Yes, if they have given you point lying on second quadrant or third quadrant, it will be open left, then it is of the form y square equal to minus 4ax. Accordingly, you have to judge your curve. Now it is clear it is of the form y square equal to 4ax. Now we need to know what is the value of a. That's why they have given you a point. If we substitute the point, we will come to know what is a. Once we get the value of a, we can again resubstitute in our equation y square equal to 4ax. Then we will get our parabola equation. Yes, hope you understood. The same way you can solve the 12th question. There they have given you it is symmetric with respect to y-axis. If it is respect to y-axis, it can be either upward or downward. And it passes through the point 5, 2. Again it lies in the first quadrant. Therefore, it should be open upward. And hence it is of the form x square equal to 4ay. Accordingly, you can solve the problem. So in today's class, we have learnt about in detail about what is meant by a parabola, what are the standard equations of parabola, where its focus, vertex, directrix lie according to each standard equation we have learnt, and how we derived the standard equation, and we even learnt what is meant by latus rectum and what is the value of the latus rectum, and we have solved problems on it, right? So with this, let us wind up today's class, and your homework is going to be exercise 11.2, question number 2, 3, 4, 8, 9, 10 and 12. And you have to complete the homework and post it in the group. If you have doubts, you can ask me. In the next class, let us learn about the next conic section called ellipse. Thank you, students.